Alright, so this is a review of a matrix. Here we're going over each question that you saw on the Chapter 4 review from the textbook. So make sure you have your worksheet out, make corrections where you made mistakes. If you make all those corrections, you will get full credit for the assignment. Alright, so first of all, we're talking about the matrix, and there's a lot of operations we do with the matrix, multiplying matrices, different things like that. So we're going to go over each in a rather brief detail, but you can always run the video if you have questions. So, first one. Working with matrices. So we have our different matrices here. We have matrix A. Kind of just visualize the brackets because the computer doesn't allow me to make brackets for the matrices. So just try to visualize them as we go. But these are your two matrices. Right now what we're doing is we're identifying the dimensions of the matrices and some values within the matrices. So numbers 1 and 2 ask you to divide the dimensions of the matrices. So matrix A. Remember, when we write it, we have our subscript representing the dimensions. Remember, the first number that we put here represents the rows, the number of rows in our matrix, and this number represents the columns, okay? So, the rows in A are 3, the columns are 2, so it is a 3 by 2 matrix, okay? For B, we have 2 by 3. 2 rows, 3 columns. Alright, that's how you represent those first of all. Now, the values of the different numbers. Remember, when we are finding something such as A12, which is one of your problems, the number in the tens place represents the rows, the row it's in, and the one in the ones place represents the column that it's in. So, A12 would be equal to -1. Okay, -1 would be our value for A12. How about B21? For B21, our value would be, it's in the second row, first column, so that would be -4, okay? Second row, first column, 2, 1, okay? Now it's asking us the element whose value is -2. So -2, we see one in A, it's in the second row, first column, so the -2 value would be A21, okay? And then the element whose value is 1, that's in the first row, second column. So that means it will be B12. Okay? That's a pretty straightforward section for matrices. You just have to identify where they are in the matrix. Alright, creating matrices. Let me move my little face over here. Alright, so creating matrices. So now we are taking these graphs and we are designing matrices based on them. What I'm going to do is I'm going to create a 2 by 5 matrix for this one. My rows represent my different points, A, B, C, D, and E, and my columns are X and Y, okay? So A, I'm going to start with A, going from A to E. A is -2, 3, so I'm going to put -2, 3. B is 1, 1. C is 3, 4. D is 2, -4. And E is -3, 1. Okay? You can also make a matrix that is X and Y with the rows being X and Y and the columns. That would be a 2 by 5. This is a 5 by 2. The dimensions of this one are 5 by 2. I made a little mistake in identifying that. So that is one matrix you can make. Another one, I'm going to make this one horizontal so that you can see that as well. So X, Y, A is 2, 4. B is 1, -4. C is -2, -2. D is -3, 2. Okay? Same thing, just a little bit flipped, okay? Flip 90 degrees. So it's the same type of matrix here. Alright, so matrix operations. So I'm only going to do 2 of them. The other 2, numbers 9 and 11, you will have available to you in the back of the book if you want to find the solutions for that one. But these ones I'm going to go over just to show you how to perform the operations. So you have 3 matrices here, A, B, and C. A, B, C is easy as 1, 2, 3. So A, B, C here, and then it's showing you different operations it wants you to do. So when we do these operations, we apply the given operation to the corresponding terms in the matrix. What does that mean? So A plus C. What I'm going to do here is add the corresponding term in A. Say I wanted to add the term -5 to the corresponding term. That means I'd add -5 to 0 because in the matrix, they are in the same location, okay? So -5, so let's do that, all right? Let's make our 2 by 2. For these matrix operations, your matrices have to be the same dimensions, okay? There can't be a difference in the dimensions, otherwise it will not work for these types of operations. So 5 plus 0 gives me, well, -5. Next corresponding terms are 6 and 2. 6 plus 2 gives me 8. 1 plus 8 gives me 9. 7 minus 4 gives me 3. Okay? So you just look at the term, compare it to the corresponding term in the same location, and perform the operation. Okay? So that is your answer for that one. All right, let's do 7b minus 4c. So that means we are multiplying b times 7. So each term is being multiplied by 7 here. So let's make that matrix. 9 times 7 is 63. Then -2 times 7 is -14. 7, 21. Okay? So I just multiplied all those terms by 7 minus the terms in C multiplied by 4. Okay, so we're going to multiply those by 4 now. 0, 8, 32, and 16. -16, sorry. All right, so if you end up performing those given operations, remember when you're subtracting the corresponding term. 63 minus 0 gives you 63. And if you were to finish it, you do -14 minus 8. So that is -22. Make an error in this, I'm sorry. 7 minus 32. So that will be -25. I had to do the math myself. -25. 21 minus 16 gives you minus a -16, so you're adding this here. Two negatives make a positive here, remember? It's -16. So 21 plus 16, because it's two negatives. 21 plus 16 will give you 37. That's what you should have as your final answer. All right, solving for x. So you're solving the given matrix equations for x. You're treating this pretty much exactly the same as solving a regular equation for x, except you are also applying each rule to the terms in the matrices. So remember, matrices do have brackets. It's just I can't do it on the computer. So, all right, let's work this out. So we're trying to isolate x on its own side. First off, we have a 2 here. We want to multiply these values by 2. So let's do that real quick. 2 times 6 is 12. 2 times 5 is 10. 2 times 1 is 2. 2 times 3 is -6. All right, so that's done. And we have our minus x, and then our other matrix. So in order to isolate x on its own side, I have to subtract this matrix from both sides. If I subtract this matrix from itself, it cancels itself out. So that means we're subtracting the same matrix on the other side. All right, so we're doing that. Now we have -x is equal to, now we have to solve these ones. So 12 minus a minus 2 gives me 14. 10 minus 0 is 10. 2 minus 3 is -1. -6 minus 4 is -10. All right, so you should have that all set. But we have a -x. We can't have a -x, so we're going to have to multiply both sides by -1. That'll make everything in the matrix its opposite. That's how you solve that one. All right, this one, I could go through the whole process of solving it, but really the first thing you have to do is multiply everything here by 3. I'm actually going to go through it real quick. 6. 9 times 3 is 27. -7 gives times 3 is -21. -4 times 3 is -12. So that's your matrix there. And then you'll have to, since this matrix is being subtracted, you're going to have to add it to both sides. 2x. All right, so you add this one to both sides. That will give you 2x is equal to 6 minus a minus 6. Or no, 6 plus a minus 6. Because you're adding this to both sides. 0. 27 plus 7 gives you 34. Negative 1 plus negative 21 is negative 22. 8 plus a negative 12 gives you negative 4. That should be correct. All right, and then you have to divide it all by 2, and that will give you an answer of, well, again, 0, 17, negative 11, negative 2. That's your answer for that one. That's how you solve those. You just apply the same operation, but to the corresponding terms when you're adding or subtracting. Order of operations is still the same for these, so make sure you pay attention to the order of operations when you're doing this. All right, determine the matrix dimensions. So remember, when we're determining matrix dimensions, we're determining when we multiply the dimensions together, what the final matrix is going to be. Key thing about multiplying matrices, you have to have the same number of terms in your first matrix, same number of columns in your first matrix as there are the same number of rows in your B matrix. If these two numbers are not the same, the matrix will not work, okay? So, determining the matrix, remember, so these are what we look at to see if it's a possible matrix here. So, don't worry about those after you figure it out. This is a possible matrix. These are what our matrix will end up being, okay? So, if we multiply them together, it's going to have 4 rows and 3 columns. It's going to be 4 by 3 if we multiply it together. A and B, pay attention to the number of columns in A and rows in B. These are not the same, so it is going to be undefined. I'm just going to put undef. It's going to be undefined because these have to be the same in order for it to work. All right, multiplying matrices. So remember, when you're multiplying matrices, you are applying the first row to the first column to find your first term, first row to your second column to find the second term, okay? So, in order to multiply this together, in order to find this value right here, since in the first row we multiply it by the first row of the first one, since in the first column we multiply it by the first column in the first row. That sounds a little bit confusing, but first of all, 2 times negative 6 gives me negative 12. 7 times 2 gives me 14. If you add those together, it gives you 2. Now, what do I do with that 2 value? Right, put it right there, okay? Just think of where it intersects in relationship to the row and column of your matrix. That's where it goes, okay? All right, next up, we need to find our term right here. That would be the first row, second column. So 2 times 0 gives me 0. 7 times 1 gives me 7. That gives me, well, 7. Okay? Second row times first column. 5 times negative 6 is negative 30. 6 times 2 is 12. Negative 30 times 12, or plus 12, gives you... Oh, it's negative 5 times negative 6. 2 negatives make a positive, so 30 plus 12 gives you 42. That's second row times first column to find this one, okay? Think about it as second row, first column, and what is this term? 21, if you were to figure out where it was in relationship to the matrix. Okay, so that's 42. Second row times first column, negative 5 times 0 is 0, 6 times 1 is 6, this is 6. And then if you were to solve the other ones, you'd get negative 10 and 4. That's how you multiply matrices. You do first row, first column to find this one, first row, second column to find the second one, first row, or second row, first column to find the second one, okay? So you kind of just have to see the relationship between the row and the column, okay? So if I were finding 42, which is located at A21, I'd do the second row, the 2, times the first column, 1, okay? That's the relationship you need to remember if you have questions figuring out how to multiply a matrix. Write this as a matrix equation. Remember, when we write as a matrix equation, we set up when there's two variables, a 2 by 2, x and y are our columns. And then in this second matrix here, x and y equals our solutions to it here, or our whole numbers that we have. So our x values are 8 and -1. And then our y's are pretty straightforward. It's 1 and 1. Now, if you were confused on how this was set up, you can always change it back to regular. In fact, you do need to change it to the standard form in order to solve this just right. I realize I made a mistake here. And I'll explain why in a minute. So this is your starting setup, but first step, change this to regular form, okay? So you have to move this out of slope-intercept and take it back to regular form. -8x plus y equals -21. I took the 8x to the other side. X plus y equals 16, okay? So y equals 8x plus y equals 21. So you have your -8, 1, -21. And then here you have 1, 1, 16. That is your matrix equation. So change these to regular form before you just plug them into the matrix equation. Determinants. This is kind of the toughest part of the whole topic, okay? So finding determinants, remember, when you're finding a determinant for a 2 by 2, you're doing your majors plus your minor. Okay, your major plus your minor. Remember, your major values for a 2 by 2, making it pretty simple, are 6 times 3. 6 times 3 is your major. That gives you 18. So it's the first and the last term. And then your minor is -5 times -4, which is 20. Your determinant, this is number 25, is, oh, sorry, you're not adding it here. You're subtracting it. So you're subtracting major minus minor, okay? 18 minus 20 gives you a -2. That's your determinant. So subtract the minor from the major, okay? Same thing for a 3 by 3, except there's 3 numbers you have to find before you can subtract. So we're going to use some different colors to help identify these, but kind of picture this matrix here as right next to, picture a copy of it right next to it if it helps you. I'm going to do that just to see if it helps you. So to find the determinant, picture the same matrix right next to it, and I'll show you why in a second. So this is your matrix. To help here, I'm going to erase this here. Excuse me. So what you're doing is you're finding 3 major values. So MJ1, in fact, let's use a different color for this, green. So MJ1 plus MJ2 plus MJ3. All right, what does that mean? What does that mean? So you're finding 3 major values, and you're going to subtract it from 3 minor values. What are my 3 major values? Well, it's going to be -2 times 0 times 7. Okay? That's your first major value. Once you do that, -2 times 0 times 7. -2 times 0 is 0. 0 times 7 also gives you 0. Okay? That's your first major value. Your second one will be -3 times -1 times 5. So think about it. So you have your first, this value, and this value are being multiplied together. Having a copy next to you just helps you visualize where that might be. Okay? In case you have difficulties visualizing that. So 3 times negative 1 gives me positive 3 times 5 gives me 15. Okay? So 15. 9 times 1 times 4. 9 times 1 gives me 9 times 4 gives me 36. Alright, so major values are done, but we're not finished yet. For a 3 by 3, we still have to find the minor values. So minor values include mn1 plus mn2 plus mn3. Okay? So for these values, you are still multiplying diagonally, but you're doing it in a different way, okay? You're starting with the bottom value of your first column, multiplying in an upward diagonal path, okay? So 5 times 0 gives me 0, times 9 once again gives me 0. 4 times negative 1 times negative 2 gives me positive 8. I believe so. Let me check that, but I want to make sure I'm doing my math right here. Yes, positive 8. Then, your last one is 7 times 1 times negative 3, which is a negative 21. Alright, so it's just taking the diagonals and multiplying them. Then, once you have your majors and your minors together, you add them up, okay? So, when you end up adding these up, you will get, and subtracting, do your final subtraction, you'll get 64 as your determinant. That's how you do it. I know it's a long process, but you will have to use this process when you are using Cramer's rule to find x, y, and z, or x and y. Cramer's rule. So let's start right off with that. First of all, we have to create matrix A, okay? Matrix A using the equation, okay? So let's do that real quick. Matrix equation A, 3, 2, 1, 1. We're taking our x's and y's here, times x and y equals 9, 1. Okay? Now remember, when using Cramer's rule to find x and y, we have to create matrices for x and matrices for y. So we're going to do that real quick as well. So matrix A of x is exactly the same as this matrix up here, with the exception that you replace the x values here with the solutions, okay? So 9, 1, 2, 1, okay? All right, so that's A of x. A of y is 3, is the same except you're replacing the y values with the solutions. So 3, 1, 9, 1. Okay? So these are your matrices. Now you will find the determinant of each matrix, okay? So determinant of each matrix, first off, let's find the determinant of A. Determinant of A is 3 times 1 is 3, minus 2. Determinant of A is a very simple 1, okay? I believe. Can I make certain of that? Yes. All right, determinant of A of x. You need to find each determinant. Determinant of A of x is 9 times 1 gives you 9. Oh, that's not right. 2 times 1, 9 minus 2 equals 7. That's your determinant for A of x. A of y, 3 minus 9 equals negative 6. Okay, so you have your 3 determinants. Now, to find x, we divide determinant of A of x by the determinant of A. Okay, So our original matrix will divide up the determinant of a of x. And if we were to divide 7 divided by 1, that gives us 7. So x equals 7, y equals negative 6. Because we do a of y divided by determinant of a as well. Alright, that covers everything from this chapter with the exception of finding the area of a triangle. You guys did that. You create a matrix using the given vertices, and remember, for finding that, you have 1, 1, 1, x1, x2, x3, y1, y2, y3. So you use this matrix here to come up with the area of a triangle using a determinant, okay? So keep that in mind. Make sure to take a look at that rule. We might look at it in class before you guys take the test. I want to make sure you guys have this particular situation down. But if you were to have x, y, and z for Cramer's rule, first of all, you would use a 3 by 3 matrix and do the same method, finding the determinant, dividing the determinant of a given variable by the determinant of the matrix. So that's all from this chapter, and let me know if you have questions. Hopefully you can do quite well on this test tomorrow. All right. Well, let me know if you have questions.